Good day everyone. Today you will learn two more concepts in lines and planes. The first one is to prove a plane contains a line or a line lies in a plane. Okay. Now look at the figure. A plane we always represent by a parallelogram. This AB is a line which lies in the plane. Now actually there are two conditions you have to prove. The first condition is any point, okay, on the line AB, on line AB or whatever it is, on a line should lie in the plane also. So you have to find some general point on the line and you have to prove that lies in the plane. Then the second condition is the normal to the plane should be perpendicular. The normal to the plane should be perpendicular to the line. That is, see now this is the plane and this is the line. This will be a normal. Normal means any line perpendicular to a plane. So naturally that should be perpendicular to the line if it contains that line. So these are the two conditions. Now just one example sum let us see so that you will understand it better. Now the plane equation is r vector dot I cap minus 3j cap plus 5k cap is equal to 7. You have to prove this plane contains a line r vector is equal to I cap plus 3j cap plus 3k cap plus some lambda times 3I cap plus j cap. So this is what you have to prove. This plane contains this line. Okay. So the plane equation let us take it as 1. The line equation let us take it as 2. If you convert it into Cartesian, it will be very easy. So let me write the Cartesian equation of the plane. That is x minus 3y plus 5z is equal to 7. Okay. Similarly, I will write this one. X minus 1 by 3 is equal to y minus 3 by 1. That is z minus 3 by 0. This is my 2. This is the plane and this is the line in Cartesian form. How will you find a general point on a line? You will equate it to some constant. Let us equate it to k. So now I can find any general point. Okay. On line 2 is, take these two, your x will be 3k plus 1, comma, your y will be k plus 3. Here the z will be 0, then plus 3. So this is any general point on line 2. Now, if this point lies in this plane, we can say any general point lies in the plane. So the first condition we will be proving. So now, let us take the LHS here. Okay. So I will put for x 3k plus 1 minus 3 into k plus 3 plus 5 into 3. That will be 3k plus 1 minus 3k minus 9 plus 15. 3k you can cancel. 15 plus 1 16 minus 9 which is 7 which is RHS. So we have proved that the point satisfies the plane equation. Therefore, you can say any general point, any point on line AB lies in the plane, right? So now the first condition is satisfied. Now what is the second one? You have to prove that the normal is perpendicular to the line. Whenever you want to prove two lines are perpendicular, prove that the sum of the product of the drs is equal to 0. So let me write drs of the normal to the plane. Drs of the normal to the plane. You can find from the equation. What is that one? 1 minus 3 and 5. Let me write the drs of the line. Okay. The given line, I will write the drs. So see the denominator 3, 1 and 0. So now I will find sum of the product of the drs. I will check whether it is 0 or not. Okay. Sum of the product of the drs is equal to 3 into 1 3 minus 3 into 1 minus 3, 5 into 0 0. This and this goes, so you get 0. Therefore, the normal is perpendicular to the line. So now we have proved both the conditions. So now I can say the plane contains the line or the line lies in the plane. Okay, is this concept clear to you? So always remember, you have to prove the 2 points. So in any sum where this concept you have to use, you have to prove these 2. Now let me tell you another concept which is very easy. Now you are going to prove, or you are going to find out the condition when 2 lines are coplanar. That means when 2 lines lie in the same plane, what is the condition? Then you can also find the equation of the plane containing them. Here, if I just give the basics, it is enough. You can yourself work. Okay. First, I will tell you what is the condition for 2 lines to be coplanar. First, let me consider the equation of the line as x minus x1 by a1 is equal to y minus y1 by b1 is equal to z minus z1 by c1. This is one line. Okay. The second one, x minus x2 by a2 is equal to y minus y2 by b2. That is equal to z minus z2 by c2. Let this be the second one. Now, the condition for these 2 lines to be coplanar is, okay, now determinant x2 minus x1, y2 minus y1, z2 minus z1, then a1, b1, c1, a2, b2, c2 is equal to 0. If this condition is satisfied, you can say the 2 lines are coplanar. This is very simple enough. I don't need to give you any example for this. If the equation of the line is given in the vector form, convert it into Cartesian form, and then you know what is x1, y1, z1, what is x2, y2, z2, a1, b1, c1, a2, b2, c2. Just substitute here, expand the determinant. If it is equal to 0, you will say the 2 lines are coplanar. If it is not equal to 0, you will say the 2 lines are not coplanar. Okay. So this is the first part. Then the second one is how to find the equation of the plane containing the 2 lines. For that, this is also a simple one in determinant, that is x minus x1. Now notice the difference between 2 carefully. Y minus y1, z minus z1. The second row is same, a1, b1, c1. Third row is also same. Okay. Now because it is an equation, you need an RHS. So now this is the equation of the plane containing the 2 given lines. So notice the difference, the condition, here you will have x2 minus x1, y2 minus y1, z2 minus z1. The second row and third row are same in both the formulae, so that you can find the equation by using this. The condition is, you will use that x2 minus x1. Okay, hope these 2 concepts are clear to you. So, thanks for watching the video. You can subscribe to the channel and click the bell icon so that you will get notifications of further video. Thank you.